Hey everybody! Hi, Droidcon New York. How you doing this morning? Yeah? Good to be back. All right, we're gonna have a little UI group therapy session. How many of you have ever done custom views in the old Android view system? Raise your hands. All right, keep your hands up if you didn't like it. Is that mostly everybody keeping their hands up? All right, how many of you have done custom layouts in Compose? Okay, that's a similar amount. That's not kind of what I expected. I was actually really surprised. So I'm going to continue with the group therapy session and then maybe talk a little bit about how I use custom layouts. Hi, my name is Huyen Tue Dao and I freaking love custom layouts. You might say it's my golden hammer occasionally, but you know, I do think, so for those of you that didn't raise your hands and that haven't done custom views, I do understand that custom views, especially in the old Android view system, have a very bad reputation, and it's kind of deserved. But what I really want to do with this talk in particular is just to, again, work on the group therapy session and encourage everyone that, you know, whereas before in the old view system it seemed like something really, you know, really esoteric, something really like funky that was just really not really worth the trouble that you would go through, that custom layouts, especially in Compose as we do now, are a super valuable tool and actually a lot of fun. So we're going to do that. But we're going to kind of step back a little bit and ask why custom layout. So that's kind of like a very fundamental question, and maybe an easy question. Why would you ever want to do a custom layout? Why isn't, especially with Compose, when we have so many awesome new toolkit, you know, items out of the box, why would you ever want to do a custom layout? Well, let's say that your layout logic is just too outside of the box for the out-of-the-box components. Of course, then you would need very specific UI logic, and it's not even just can you literally do a thing with, you know, the Jetpack Compose components, but can you do it efficiently, and can you do it maintainably using standard composables? The answer to that question is not always clear, but that could be a reason to consider custom layouts. So we're going to talk about performance for a second, which is always kind of like a tough subject. And yeah, there is a reason to use custom layouts when you want to squeeze as much performance as possible from your UI. Of course, big, you know, red flag, waving arms, like don't over or pre-optimize your layouts. Of course, for all my Android fans out there who have like very long established, you know, long running successful apps that, you know, have to like really tune that performance, that have your own performance teams, very jealous over here. I get that this is not really advice for you, but especially if you're doing Compose for the first time, you're starting a greenfield project, or you're actually starting to integrate Compose into your apps for the first time, there is some decent advice there to not over or pre-optimize. But that being said, if you do in fact, you know, test your app and find some jank, or find that, you know, in Compose you're recomposing more than you should, custom layouts, believe it or not, is an option. So I'm not going to go any more into this, but actually very recently, if you are already a custom layout / Compose veteran and you really want to get up into the nuts and bolts of Compose, you know, performance, there very recently was an episode of Android Developers Backstage where, you know, a lot of the members of the Compose team go into all sorts of bits and bobs and specifics, even talking about R8 and unboxing and boxing and unboxing and all kinds of stuff like that. If that's your jam, you should definitely take a look at it. But there are some like really interesting concepts that I will kind of reflect on today about what was said during this podcast, but you should listen to it because they will talk about stuff way better than I ever could. So this is kind of something that's a little bit different. Now I'm saying flattened hierarchy, and some people are probably thinking, ooh, views, constraint layout. I know the answer to this question, performance, right? Not necessarily. So a lot of times, you know, as we're doing UIs, you know, I know that usually, again, this flattening thing is always been about performance, because we know that on the Android view system, linear layouts, relative layouts, super bad. It can do like double measure layout passes, and oh my God, if you nest them, then it's like multiples and multiples and multiples and multiples. That is all true. But just because we have this new declarative UI framework, right, we have this wonderful toolkit that, you know, is really meant to kind of address some of the, I would say sins, it's not quite right, but they have some of the difficulties of the past, right? Especially with these kind of like layouts that would have this like multiplicative, you know, measure layout issue, right? So now we have this framework where, you know, a lot of the burden of performance of making these decisions, the Android team has kind of taken the burden off of us and kind of put onto the Compose framework, which is awesome. And actually, this does touch back to what the Android Developers Backstage podcast was. And I remember Leland Richardson is talking about, you know, kind of performance, like memory, all that kind of stuff. And there is a point to, like, yes, the Android team has done a really laudable job making Compose easier in that we do not have to be quite so fiddly with how we nest things. You can feel free to put a column in a row and put that row and column in another row and column, and there's going to be very little performance impact. But it's not zero, and Leland actually made a point to say this, that while they have reduced the resource cost of each of those allocations or each of those containers to quite a small bit, if you're just going to nest with reckless abandon and just nest 50 layers down, then you're still good. Even 0.1 added many times will result in not 0.1. But there's kind of more to that. Again, stepping aside from performance, a lot of times the benefit of Compose and kind of other modern tools like Kotlin, things like this, is that we've kind of gone as engineers and software developers from going from super low level, think zeros and ones punch card, to talking about architecture and services and all kinds of high level concepts. And as technology, as our platform evolves, we continue to be able to talk at higher levels of abstraction, right? And so the benefit of Compose is that we can now more naturally talk about UI, right? We don't have to just stick everything constraint layout, sort of make it work, hope it matches comps, and just leave it and don't ever touch it. We can say, hey, think of higher level abstractions, and you can write your UI code as you would kind of organize it and lay it out in your head. Where yes, of course, if I'm looking at this form, okay, so I have it's generally vertically laid out, but each section might be a little bit different. Where okay, I have a box, but there's a couple rows in there, but oh, this row might have some 4 columns in it. That's kind of how we think as human beings. Now, Compose is letting us get a little bit closer to being able to just think code, more or less. We still have to type it out, but we kind of get closer to a more higher level abstract way of thinking about UI. But there are non-performance reasons to maybe rethink this, not necessarily always go for rows and columns and just using the simplest terms, right? So, I mean, just plainly speaking, yes, this would be probably is totally fine performance-wise, but as we keep nesting and nesting and nesting, what happens is not a performance problem of the code so much as a human performance problem where, all right, we're getting to that brace hell thing where things are just getting more and more indented, more like the Christmas tree thing, almost like coroutine callbacks or something. And what happens is there starts to be a little bit of a difficulty in correlating where I am in the code and where I am in UI. And sure, that's kind of a nesting problem, and you could totally break up into subcomposables. That's totally planned, but I'm here to also tell all of you that didn't raise your hand that you use custom layouts in Compose that even though we have this liberty to really just use a lot of these, lower level, out of the box, super solid primitives, in this way and not really worry about performance, that there's still a benefit to human performance, human grokability, human productivity to kind of rethink things. And if you think about language, right? So say I try to give this talk to y'all at a second grade vocabulary level, right? I could do it, but it would take longer, and some of the meaning might be lost, right? In some of those, using simpler language, using simpler constructs. In order for me to efficiently and also clearly communicate to you what I'm trying to communicate to you, I do have to kind of reach in and use some more slightly complex terms, a little more complicated, syntax or ideas. And I think the same thing can apply to even UI code, just like any other code where, yes, there is a big value in just having, brain to code transmission and just having what you think pop out, and it works. But for, teammates who have to read your code for you 6 months from now, or even just in terms of correctness and being able to come back in here and reason, add more things, sometimes it's not just about, okay, let's use the kind of most straightforward path and then break it up. Sometimes it is hey, maybe the most straightforward way of communicating a layout, a behavior, is to actually use something more complex like a custom layout and be very particular, be very precise, and be a little clever, be a little complex, be a little sophisticated, but then you can more clearly communicate the idea, and then hopefully not have to explain to yourself 6 months from now what the heck you did. So I wanted to touch on this really quick. If you know me, you know that I used to talk about constraint layout a lot, and we've talked about flattening and views and performance. And I remember when Compose first came out, I was all like still very, very hot on the constraint layout like train, and I was saying, well, I don't want to use Compose if it doesn't have constraint layout in it. All right, I'm gonna eat those words right now. I actually would say today, as I am now, especially having played around with custom layouts for both myself and for production code that I have done at jobs, I actually would prefer custom layouts over constraint layout, and I would actually suggest to people that rather than going constraint layout, you actually experiment with custom layout, which seems kind of backwards to what I used to say with Android views, and I'll tell you why. So, the way that constraint layout API is now, it's very much a very direct translation from Android view system. So that means a few things. There's still view concepts in there. Like you can see here, we have margins. Margins don't exist anymore in Compose, right? We have a different model of spacing and padding. And constraint layout is very, very still reliant on IDs and references. These are things that we are very much less dependent on in Compose. And so, especially if you're someone who is, bless you, never had to do views and are all Compose all the time, this might not actually be, kind of a way forward for you. It might just kind of be a good thing if you're, on a code base that's legacy, y'all are just have constraint layout and you have a system built around it, or that's just how you want to do it, which is totally fine. But if you want to ask my official opinion, I really do think that in lieu of constraint layout, if you're finding yourself trying to do something really interesting and sophisticated, try custom layout. All right, so yes, does it making custom layouts suck? And I feel like that, a lot of times in the past when I was trying to get people excited about custom layouts, yes, they do suck on Android views. Do they suck in Compose? Absolutely not. But to explain really, really carefully why you should be excited about custom layouts in Compose, I'm going to try to explain why it was kind of sucky on the view system. And honestly, a lot of it has to just do with the view system. And not that the view system is wholly bad, but it is a system that we've moved away from because of certain things. And a lot of the reasons that things like custom views, custom Android views were very confusing is just the inherent nature of Android views, right? With Android views, every single widget, every single view is a stateful object. And then you have 2, 3 dozen, 100 of these things with state that you have to keep synced. A user clicks on something, and then you have to make sure that every single, third object that needs that state gets it, that it's all coordinated, that no one updates too fast in the other one, or update lag, or someone kind of intercepts, and all that kind of stuff. Having to manage and synchronize and keep coherence of all this different state was just an inherent limitation, feature, characteristic of the old view system. So yeah, that just makes having to go into the low levels of custom layout super hard. But if any of you have really dug into the custom views back at the Android view system, oh my gosh, it is like a whole other world. You would make Android view layouts in XML, and you'd have these lovely tags, you'd have your buttons, your linear layouts and everything, and it would be kind of like a modern, civilized UI making world. And then you go into custom views, and it's like a whole weird, strange planet where you have these weird esoteric APIs for not just lifecycle, but inflation, and sometimes they don't work. There's themes and stylings, which, yes, are CSS and XML on the outside, but the inside have all these weird arrays with typed attributes, and it's all kinds of stuff. And then also, don't even get me started on layout parameters and drawable state. There's all these really specific, highly specialized APIs that we'll say day-to-day Android does not even have to touch, right? It's already done for us. And then to go and say, hey, I need something more than the platform can provide, and then go down there and see that there are dragons and monsters, and what on earth is this kind of what's Lovecraftian horror that is under there? That's kind of part of it. And then of course, we had XML, and it's sort of declarative, but really everything was still just Java objects, right? And there was a separation of declarative and imperative stuff, but it was kind of not really separated. They're still kind of mixed, and you can still have Java constructed views with XML views, and so it's not quite the clean, fusion of coding and UI that we have with Compose. And of course, along with that is plenty of boilerplate. So yes, if you ever did something like this, and this is obfuscated production code that I actually wrote, that has basically all these things, then yes, I totally get why you look at that, and maybe 5 years ago you looked at that and said, no hell way, I am ever going to do that. Yes. So why should you change your mind if you are not one of those people that raised your hands? Well, One of the things that was really weird, again, about view groups and custom views in the Android view system is that once you got to that slightly lower level, again, it was like hopping onto another planet. It was like a different kind of style, or not even style, but just like different, basement of Android development that you had to go and live in. And, there's a lot of things that you do there you just don't have to worry about when you're just able to stay on that XML, surface level. With custom layouts in Compose, you don't have that weird disconnect of going somewhere else when you want to do custom. Custom layouts and the way that you can do things custom, can you do things custom, is that the right adverb, in Compose, is just like the rest of Compose. You have modifiers, you have layouts. You don't have to create like a whole different class just to hold your custom layout. It can just live as a composable with everything else and have all that logic there and be accessible and readable, and you can kind of understand the context of it, and it's not just locked away in that weird like view/view group custom basement. And because it's more integrated into our day-to-day like Compose UI lives, a lot of the things that we are all doing, even if we're not doing custom Compose, but all these things that we're learning about, right? Like how to properly like hold and hoist state, like how to apply best practices of like controlling recomposition and understanding data flow. They work the same inside a custom layout as well as they work the same inside as well as outside of a custom layout. Again, there's no barrier of, okay, you hopped into low-level world, things are a little bit different, you got to think a little bit differently. You can just naturally start experimenting with custom layouts and apply the same best practices, learnings, and everything that you have been doing to custom layouts. And I mean, if you just want to be nice, the Android team actually specifically tried to make custom layouts easier. In the documentation, they explicitly state that they had two main goals in making this layout system. Number one is, of course, high performance. And number two is ability to easily write custom layouts, because it is such an important tool. There are so many times where you look at the docs and you look at the code labs and that's a really awesome example. I have 15,000 things that are more complicated than that, and I don't know how to do them, right? I don't know how to do this with just the regular layouts. So you need to kind of be able to go in there and be very explicitly like, hey, I need this thing to be over here, and then when this button is enabled, then I need this to go here. You need to be able to do all of that. And the team has really, really, really made it so that second bullet point is actually pretty true. So how do we get started? Well, we're Android people, so we always start with the life cycle. Except this time we're actually going to call them phases. And so if you're an old school Android dev, and you're very familiar with the view life cycle, you'll be very happy to know that it's very analogous to the Compose phases. We're going to call them phases. And of course, just like with everything else, if you want to start, building out a UI, you need to take your code and create a representation of that UI. So back in view lifecycle world, we had view hierarchies that were either directly constructed from Java constructors or inflated using XML, and these things were inflated into a literal hierarchy of these view objects, right? They're just Java objects sitting there waiting to be managed and handled. And the way that they continue to be processed in order to be rendered is first by doing something called measure, which you measure like the children of any view group and then the view group itself. And then of course, laying out where you actually put that measured thing on the screen somewhere. And then finally, Android will draw it for you. So there are very, very analogous, kind of phases. Well, they are phases in Compose. A little bit different though, especially when it comes to composition, not surprising since it's Jetpack Compose. So rather than, whenever we create our, view hierarchy representation, our view tree, rather than actually creating objects, we're calling composables, we're calling functions, right? And so these functions will determine what actually is created, what is actually living inside of our UI hierarchy. And their functions, and when they're invoked, they don't create like little Java view objects, they emit, these nodes that become part of this in-memory representation of the UI. And so composition is like, okay, what is in my UI? What is actually going to show up? And then we have to ask, how does it show up? So if you look at measure layout on the view lifecycle, just think of squishing those things together and just calling all that layout, because that's what the layout phase in Compose is. There's measurement, measure the children, measure yourself, and placement, placing things on the screen, and then of course drawing. So as you can see here, we're not too far apart in terms of terminology and idea and just the general flow of how things go from representation to something to drawing, right? It's very analogous, but we have all the benefits of compose. So there's this really cool concept of phased state reads. So at this point, if you're using compose, you're probably already familiar with the idea of, hey, I need to carefully manage my state so that I don't trigger too many recompositions, right? You need to be able to determine, okay, I'm not giving too much information or I'm not exposing too much state that says that when it changes, I'm redrawing things that actually, or I'm recomposing or remeasuring or relaying out things that actually don't need it, right? That's our responsibility to manage that state. And if we do that correctly, the benefit is that compose is able to skip things, right? So if state changes, but you have a part of your composition that doesn't give a damn about that state, compose will actually skip, kind of composing that state. But it's not just at that granularity where, okay, all of these things free happen or they don't happen depending on state change. Each of these phases has particular state that they read. And so phase state reads is basically that each of these phases knows what states it needs. And if the particular state that a phase needs doesn't change, then it skips it. So you could do composition, you could skip any of these phases basically. So there's an even finer granularity of skipping work that compose can do. And again, this is kind of just an extension of what we're already doing with compose, right? We're already learning about, again, state hosting, managing state, knowing what things change, like what parts of our UI change in regard to state. Now we're just kind of being able to kind of take that knowledge and take those concepts and apply it to even deeper levels of the rendering process. So let's actually talk about, what's under the hood. So what I think is really, really cool is that, like, kind of back in the old, Android view system, Android view system. Okay, we did have very specific functions that you would override, right? To do measure, to do layout, to do draw. But at the same time, there's all this black box around it. There's all these kind of like variables. There's all these kind of like rules that you just had to know to follow. And while that's not untrue in Compose, what I really think is interesting is that the way that Compose layout is laid out is that there is a much stronger, connection between these three phases. What you do with them, what state you give them, how you calculate what should go where and how big it should be. And also, the literal, how you code it in the code. It's pretty lovely. So let's take a look. So layout here, the inner layout composable is the building block of compose layouts. If you look in box, if you look in row, I think even if you look in lazy list, you'll see layout. You might see a subcompose layout, but you'll see layout. And again, if we just look at this, and this is from the Android developer docs, if we look at this implementation of layout, we can actually literally map each of these phases to very specific parts of the code. So composition more or less happens in the content lambda here. So that's, again, the innards of your layout, whatever buttons, sliders, chips, whatever you want, drop-down menus. The actual content of the layout is in the content. And so as we're calling those composable functions, as they're getting invoked, emissions are getting emitted, and basically, Compose is deciding, okay, what's on the screen. Now that things are kind of emitted and we know, what nodes we have in this, in-memory representation that Compose creates, we need to measure these things. So when you actually get down here to this measure policy, this is where the layout phase is encapsulated. I actually kind of personally think measure policy should be called layout policy, but that's just me. But what gets passed to it are measurables. So what measurable is literally just an interface that says, hey, this is a thing that Compose can measure. Easy peasy. And then what happens is that inside of measure policy, you'll get all the measurables, all the things that can be measured inside of this layout, and constraints from parents and the individuals themselves, just about how basically determining how big, how the min width, min height, and the max of all those. And when you actually are measuring this, you take these measurable instances and you call measure on them and pass them constraints. And you get back placeables, and there is your measurement, the measurement portion of the layout phase. And placeables are just like measurables. They're an interface that says, hey, Compose can place these somewhere, which I kind of actually really love thinking about it. And you can see where the placement phase happens, because it happens right in that layout method inside of this layout, where you pass in the actual width and height of this layout. And within it, you actually can take the placeables and place them on the screen. And I just kind of love that, right? So it's a very direct, mapping of, again, these conceptual phases and then the actual code that you write. And again, with these advantages of Compose, with having these phase state reads, it just feels like a lot more control. You just feel like you can reason much more easily about how things flow to the other. And hey, you can actually see, okay, well, I can see what state is visible where and where I'm inputting what to really take advantage of Compose. And it's so interesting because Compose is a declarative, framework, and so you think that kind of almost like separates you a little bit from, all these different things, but in a way, it actually is bringing you closer together. Well, that's very comforting and warm and fuzzy. But I mean, I just think that's a kind of a fascinating way of like kind of moving on from the view system and that kind of like measure, layout, draw, hope it works too. Okay, I can very easily see how things interact, and I can very easily manipulate them to make things better, stronger, faster. So, okay, how do we actually implement a custom layout? So for those of you, again, who didn't raise your hand for custom layout in Compose, there are some pretty easy ways to get started that are very lightweight and that don't have the boilerplate and the overwhelming, esoteric APIs of the Android view system. So if you're just wanting to override or customize the layout of one particular element inside of your layout, there is the layout modifier. So it's a modifier, just like any other modifier, fill, max size, like all of our new favorite things. And basically, layout is a modifier that gives you kind of like what is very similar to the measure policy, where you get a measure scope, which kind of defines, where a bunch of measure and layout stuff can happen. You get a measurable. So in the layout, you kind of got, a measurable for every element in that layout. Whereas here, you're basically overriding the layout for one element, so you get the measurable for that element. You get some constraints, and you still go through the, process of measure, placement. All right. So that's all fine. Let's go to Android Studio. And Android Studio is way over there for me, so so bear with me for a second as I find what I'm looking for. So I do miss a lot of things about constraint layout, and one of those things is a constraint that is kind of hard to use. Let's see if I can find it. There we go. And that is circular constraints. If you have never, there we go. If you have never used circular constraints, it's basically polar coordinates for laying out. So I figured, well, since I kind of have, like, unfortunately, I don't want to say I've abandoned constraint layout, but since I, kind of said I was using custom layouts instead, let's go ahead and do polar coordinates using the layout modifier. So polar coordinates take a radius and some angle and around some center point. At that radius and around some angle around that center point, lays it out. And you can convert from those kind of polar coordinates to x, y pretty easy, right? So the fun part is, yes, I'm creating an extension method that's on modifier. But there we have this method that actually does the work under the hood of creating a layout modifier and then kind of basically allowing you to pass this override measure policy more or less to that individual item's kind of like layout phase. So, so it looks just like a lot like that other example that I scammed from the Android developer docs, where I have measurable, I measure it, I get back a placeable, I place the placeable, and of course there's some polar coordinate math over here, and then I finally, within the layout where I kind of establish what the placeable's width and height is, I actually place the thing. So I'm going to, let me see, where's Visor? Here you are, Visor. So just to prove to you that it works, because I did a preview and I mean, I could have just put like X and Y there and you wouldn't, know, and I could have just gone, you could have gone unhappy thinking that Win got polar coordinates working and I didn't. But let me launch this and show you how this actually works. All right. Sorry, I'm gonna have to drag Visor over there. Where are you, Visor? Nope, that's Finder. Oh, here we go. Visor, hello. All right. Ooh, that's the wrong. Sorry, live demos, always fun. Okay, 1 second. All right. All right, one more. Here we go. Where are we? Okay, and where's Visor? Where are you? Keep hiding. All right, and I'm gonna drag you over. All right, so what I did here was actually use my polar offset. And here, actually, let me pull up the code too. It's right here. So you can see here, here's my little polar offset modifier with the radius and angle. Angle here is actually attached to a, remember, infinite transition. And then if I go back to visor, you can see, hey, I actually am changing just the angle of my polar offset, and there it goes spinning around and around and around. And can you imagine doing this in Android view system? Like, kind of how much code that would be? I would probably give up and just be like, no, you don't get circles, you just get the hearts. Isn't that enough? But just looking at this code, which I can find down here, that's what, like 11 lines of code, and very straightforward. It's just the math, and then just doing a little bit of like, okay, I measured you, I placed you. And I just think that's just really compelling, right? We got this really crazy, probably not very practical, but very delightful animation, that just came from, again, 11 lines of being able to do some custom logic. And this is not, I mean, again, my example is a little silly, but it really isn't. This is not, nothing to do, and I was able to do it very quickly, and I was able to kind of create, a very composed, because it is a composed modifier, modifier that is able to encapsulate this very niche but delightful, layout into a single modifier, which I can use interchangeably with anything else. And I think that's just so powerful. Again, when you would do custom views in the Android view, you'd have this big monolithic thing that you spent months working on and slaving over and making look like a real grown-up component. And it was kind of just this big monolithic thing that, was people were a little afraid to touch it or look at it sideways. And again, it was big and monolithic. It just wasn't a very reusable piece of code other than just like sticking it somewhere, depending on how big or how complicated it was. But look how portable this is, and it's so lightweight and so like easy peasy. I didn't have to implement view constructor with 4 parameters and who knows what they do, and I didn't have to kind of access any esoteric APIs. I just did measure placement, and there we go. So let me just seeing how much time I have. Okay, 8 minutes. So 8 minutes to talk about, all right, what if we want to go like really ham and layout and do custom layout logic for everything? Well, we're going to go back to, wait, nope, I went back, sorry. We are going to control everything, and to do that, we're going to go back to that lovely layout composable, and we're going to go back to Android Studio. But before we do, actually, so I've actually been doing this stuff a lot at work. So I definitely have to admit that I have always been a custom layout golden hammer kind of girl. Cole, you can, Cole, my dude Cole, you can testify, right? Wynn likes her custom layouts, right? Maybe a little too much. And so, I recently was at a job where I actually was trying to implement a video editing timeline. Ooh, let me put that back so you can actually see what I'm talking about. It's hard to see, and I couldn't get code for you guys to see because I recently left that job. But imagine like a video editor, right? And imagine that these are actually clips instead of like things with UUIDs in them. And what was really interesting with this is that normally you think, okay, a video editor is basically a big scrolling horizontal layout. It has clips in it. Why don't I just kind of like load the clips into some kind of like like mini player and then just throw them in like a lazy row or something and then have it go? Well, there were a lot of things that on this job I found out that I couldn't actually do that with. So we did have this kind of concept of video clips where you give it X number of video clips and it just lays it out kind of like consecutively, just like a row. But then we also had elements that were like, say, titles, like text titles or a sticker or an effect, where they can't be consecutive. They actually apply to arbitrary points of time on this timeline. So having to figure out, okay, how do I, represent that? How do I get that together? How do I kind of coordinate these things? And I have to admit, we did try to do some traditional or I guess more standard composed ways of doing things. And because I'm a golden hammer person with custom layouts, I decided to just, okay, let's see what we do. And just to kind of show you how much better life can be when you actually go ahead, stop worrying and start to love the composed custom layouts, let's talk about what would happen if I wanted to make a scheduling app. Here we go, schedule, bring up visor. So it's just so lovely. Come on, it's like my own little loading spinner. Come on. All right, so I'm not going to do a timeline, but let's say that I am trying to write an app for my local gym, and I want to see both what classes are available and maybe what classes I have scheduled. So I might do something very much like this, where it is a horizontal layout, but I not necessarily take 5 classes all consecutively unless I'm a crazy person. I've really carved up for the day, right? I might take, well, that's still a lot of classes, but there might be gaps, right? There might be kind of some arbitrary positioning of some classes. How do I encapsulate that within, standard composed layouts? So I might do something like this. So this is actually a, row that I'm going to use to create this layout. So because this is a row, it is going to lay out whatever its nodes, its emissions, or the emitted components consecutively. But there are gaps. So what do we do when we need gaps in Compose? We have spacers. So in an effort to try to do this without custom layouts, I used a row, and I kind of went through all this rigmarole of, okay, I need to make spacers, so I need to track, the start of one class, the end of one class, and if, 2 adjacent classes, the start and end times don't meet, then obviously there's a spacer, so I have to make a spacer for that, and then I calculate the width, and then I create a spacer, I pass it as the width modifier, and then kind of a similar logic to actually calculate the width of my session. Cool. And that's actually what you see on Visor is that working. But there's a few problems here. And so what we need to do is kind of go back to thinking about Compose and those phase state reads. And this actually, I got verification on this because I did my homework and listened to the ADB podcast about Compose conformance. So the problem here is all of this junk is layout logic, isn't it? I'm really determining how wide things should be, where they should go. But where is this logic living? Where is the state that I'm creating living? It's living inside of the content of row. It's in composition. So, it's at this level with 6 classes, it's fine. But I'm basically losing out on a lot of Compose by kind of doing this in this way, right? Row takes care of its own measurement and layout, so there's not really much I can do other than individually, modifying, or adding a modifier to each element, which doesn't really make sense. If I just go this route, yeah, it's easier. I didn't have to go into custom layouts, but I'm doing a lot of layout logic within composition, which means that composition is reading state that it doesn't actually need. And I think that just makes a clear point on okay, I'm doing a bunch of calculations and stuff anyway. Maybe I should just put it where it needs to go. And if we look at it, hold on, I think it's down here. Not there, right here. So here's what it would look like the way I did it. It's not, this is not a perfect example, but this is, doing that same row, but with layout instead of the actual row component and, So the first thing you notice that I don't have to add in spacers. I can really control it. I don't have to add these spacer objects because the layout logic is locked into a specific thing, right? I get to control how things get laid out. And then so my composition, so my content, it becomes a lot cleaner. All I care about within, the actual content of layout within composition is just that session data. So session is the, class. I was going to call it class, but then, call it classes. But yeah, so you can see here it's a lot cleaner, right? I can keep the state that actually is relevant to the content and to the composition there. And then if I scroll down a bit, yeah, this is a little bit longer than the row. But as you can see here, I have measurement, I have placement, and it kind of falls into that, putting, organizing code and putting concerns where they should go. The layout code's where the layout should be, the measure code's where the measure should be, the layout's where the layout should be, and I can very clearly distinguish what state should be where, and I can put it where it needs to go. And I only have a minute left, so I'll tell you that it works, and it really does. I promise you it works. But you can kind of see here that, sometimes by trying to not go there with custom layouts, we lose out on the beauty of Compose, and we don't really make ourselves much less work. I mean, I had to put spacers in there. That's a lot of hoop jumping. So if anything else, I just want to tell you that it's worth it to try, and it will be easy. And just to kind of, I left the other job, so I can't show you my really cool layout code, but this is something I did at my previous job where this was actually, when was this, 2002? So this was a little while ago, not 2002, early 2002. And this is all done with custom layouts and custom drawing. And yeah, it took me 2-3 weeks. And imagine how would I do that with just columns and boxes and stuff. So there's a lot that you can do with custom layouts. It is not that hard, and if you take the time and use the skills that you already have for Compose and just extend them a little bit, you can do some crazy ass stuff and delight your team and your users. But yeah, that's my time, a little bit over. Thank you so much.